Okay, we're going to talk about acceleration. Acceleration of a particle on an inclined plane. Okay, on an inclined plane. So what do we have here? So we have our plane right here. Let's do our plane right here. And we have a little box or a little particle, which is sitting right here. It's sitting on your plane. Here is your little box. Okay, right there. And the box is sitting on the surface. It's sitting right here on the surface, and we got this angle, and let's call this angle theta. So theta is going to be 30 degrees, 30 degrees. And the sine of 30 degrees is going to be 1/2. The cosine of 30 degrees is going to be square root of 3/2. And the coefficient of kinetic friction is going to be 0.2 because there's going to be friction all over this surface. So the friction is going to go this way, and the box is going to move this way. It's going to move with a force. Somebody's going to apply a force, and it's going to make it move down. Okay. So how do we solve this problem? Well, let's do a body diagram. So let's do our body diagram right here. Let's do a different color for the body diagram. So let's do our body diagram right here. So it's going to come, one of the components has to be in the direction of the motion right there. Okay, and then we have our weight. So the weight is going to come this way right there. Here is the weight, completely vertical and coming down. And we're going to have here an angle. Okay, so we're going to have here, this is going to be the angle theta. So it's going to be this one. This is going to be the angle theta. And we're going to have a component for the weight. This is going to be mg, which is the weight. And this component here is going to be mg sine of theta. And we're going to have another component that comes this way on the axis. This is the y-axis, and this is the x-axis. So on the negative y-axis, we can have a component which is going to be mg cosine of theta. And we're going to have a friction force that comes this way because it's going to be opposite the motion. And we're going to have another force which is going to go this way, okay, which is the same force as this one. It's going to be the same one, okay. So what we're doing is that we're just taking this one over here. We're going to take it over there. We're going to translate mg sine of theta. We're just going to put it over the axis, okay. So it's the same one. So the green one is just mg sine of theta, and we're just gonna transport it to the axis over here. Okay, so how do we solve this one? Okay, let's see. Oh, we do have another one, which is the normal force, and the normal force is going to go this way, and this is going to be the normal force. So the normal force is going to be completely perpendicular to the surface, and it always shows up when there is a particle on a surface. So there we go. We have all our equations. So the summation of the forces in the x direction has to be equal to the mass times acceleration in the x direction. That's equation 1. Equation 2, the summation of the forces in the y direction is going to be equal to 0 because nobody's moving in the y direction. All the motion is in the x, on the x direction. Okay, so let's solve the first equation. So we have that mg sine of theta minus the friction is equal to the mass acceleration in the x direction. That's equation 1. Equation 2 would be the normal force minus mg cosine of theta is going to be equal to 0. And we can say that we have a third equation, which says that the friction is going to be mu k, which is the coefficient of kinetic friction times the normal force. So we can solve here. The normal force is going to be equal to mg cosine of theta, solving on equation number 2. And we can plug that in equation number 3. So the friction is going to be mu k, and the normal force is going to be mg cosine of theta. So the friction is going to be mu k mg cosine of theta. So we're going to plug that in the first equation. So let's go to the first equation, and we have mg sine of theta minus the friction, which is mu k mg cosine of theta, and that's equal to the mass, acceleration in the x direction. And we can get rid of the masses here. We can cancel the masses. So we got that, what do we have? We have that g, which is going to be 10 meters over second square. That multiplies the sine of 30 degrees. The sine of 30 degrees is going to be 1/2 minus, we're going to cancel the masses, not the mu. Let me put back the mu. Okay. So let me put back the mu. This is the mu. This is not canceled. What's canceled is the mass right here. The mass, the mu k has to stay there. Okay, so the mu k is going to be 0.2. We are not canceling the mu k. We're canceling the mass right here. So this is going to be 10 meters over second square. And the cosine of 30 degrees is going to be square root of 3 divided by 2, and that's equal to the acceleration. Okay, so this is going to be 5 meters over second square minus, if we do this math, it's going to be 1.73 meters over second square, and that's going to be your acceleration in the x direction. So this is going to throw you 3.26 meters over second square, and that's going to be your acceleration in the x direction. And right there, you have the solution to this problem. Thank you. And we'll continue next time.